So now that we've defined what it means to be mutually exclusive, I can give you guys a formula for finding an OR probability. Again, OR is the probability of one thing or the other happening. So the formula actually depends on whether or not the events are mutually exclusive. So what that means when you're doing OR probability, you always have to ask yourself, is there any overlap? So if they are, A and B, two random things, are mutually exclusive, that again means no overlap. So they're totally separate. All you do, if you want to find the probability of A or B, is add the probabilities together. Not so bad. You just add them together and you're done. If they aren't mutually exclusive, in other words, that means there is overlap, you still add the probabilities together, but then you subtract out the stuff that's both in A and B. So in other words, you're going to subtract the overlap. If you recall in the previous video, we counted those red triangles twice. So what that means is we would add the two probabilities together, but then we'd take out the stuff we counted twice to kind of balance things out. And I don't have the picture here to show you guys, but look back at your notes. If you recall, the two probabilities we had defined, we did probability of red or blue, and then we did probability of red or triangle, referring back to that little picture I had you guys draw. Red or blue, those are totally separate. There's no overlap between red or blue. So all we did was the 5/10 plus 3/10. We got 8/10, which is 0.8. So we just add the probabilities together, done. If we have overlap, red and triangle, there was some overlap. We had 5 out of 10 for red. We had 5 out of 10 for triangle. Then, though, we had to take out the overlap. There were two red triangles that we counted twice. And if you do that, coincidentally, it's the same answer, but you just subtract it, and you get your result there. So we're going to practice this on a couple of problems involving a deck of cards. So we're just going to pick one card out of a random deck, and we're going to look at some probabilities here, or probability. So, probability of 3 or 6. When you see that word or, I want you to think add. So we're going to add together the probability of 3 and the probability of 6. There is no overlap between 3 and 6, so we pretty much add them, and we're good to go. Probability of 3 is 4 out of 52. Probability of 6 is 4 out of 52. We're going to get 8 out of 52 for our answer right here. And if we reduce that, it'll reduce to 2/13. Second problem here, heart or black card. If you think about it, all heart cards are red, so there's no overlap, no cards we count in both. All we do then is we add them together. 13 out of 52 for hearts, 26 black cards out of 52, which is going to leave us with 39/52, which you can either reduce, it'll be, that would be 3 out of 4, or you could just do a decimal, it'll be 0.75. Moving on to our third problem here. We want a probability of ace or a club. Now this problem does have overlap. The ace of clubs is counted here in aces. It gets counted again over here. So there's one card we would count twice. All that means is we're going to do probability of ace, 4 out of 52. Plus probability of club is 13 out of 52. But since there's overlap, we have to take out the cards we counted twice. We counted one card twice, the ace of clubs. So we take out a 1 out of 52. This leaves us with 16/52, which reduces to 4/13. Or if you prefer, it's going to be 0.307 roughly. So we add them together, but then we take out the overlap because they're not mutually exclusive. Last problem here, spade or face card. So you have to ask yourself, is there stuff that's overlapping? And the answer is yes, there are face cards that are also spades. So we're going to have to subtract out the cards we count twice. First of all, though, let's do the adding part. Probability of spade, there are 13 out of 52 spades, plus probability of face card, 12 out of 52 face cards. And we have to ask ourselves, how many cards are we counting twice? Well, there is the jack of spades, there's the queen of spades, and there's the king of spades. So there are 3 face cards that are also spades. We have to take all 3 of those out because we counted them twice. And when you do this, you will get 22 out of 52, which, if you write that as a decimal, is going to be about 0.423.